Today we are going to find out how many solutions a quadratic has. And another way to put that is solutions are x-intercepts. So how many x-intercepts does a quadratic have? And it either has one of three answers. It either has two solutions, in which if I sketch a little coordinate plane, the quadratic would form a parabola and it would cross the x-axis in two spots. Or it could have one solution, so that would look like this, another coordinate plane where the quadratic just touches, the parabola just touches the x-axis at just one spot. Or I could have no solutions, where the quadratic just never makes it to the x-axis, either opens down and just doesn't cross, or opens up and doesn't cross. So those are the different types of solutions, but there's got to be a way to find out that answer quickly, and there is. It's using an item called the discriminant, which comes from the quadratic formula. Remember, the quadratic formula goes negative b plus or minus the square root of b squared minus 4ac, all over 2a. Well, what we're going to do is we're going to use this portion of the quadratic formula, just this square root of b squared minus 4ac. And you see, if they say b squared minus 4ac is greater, this means positive. It means that the number is going to be positive because it's greater than 0. So if this is greater than 0 or positive, we're going to have two solutions because of the plus or minus sign right here. Because of that plus or minus sign, we're going to end up with those two solutions. One solution if it equals 0, because if it equals 0, this just cancels out, and then we're just left with the negative b over 2a, so that would just be one solution. Well, if it's less than 0, the b squared minus 4ac is less, that means we have a negative number. Well, if it's a negative number, you see you can't have a negative number underneath the radical sign. We wouldn't get real solutions. And so that's when we say there are no real solutions, or zero real solutions. So that's what we're looking at. We're just going to use this discriminant, and so the important thing is to make sure the equation is in this form. It's got to be in the form of ax squared plus bx plus c equals 0. Just like you're solving using the quadratic formula, you've got to have it set equal to 0. So this one's all set up for us. A term is the number out in front of x squared, b is the number out in front of x, c is the constant. And so we just substitute those numbers into that discriminant. So we've got 8 squared, and then minus 4 times 1 times 16. So we go ahead and do a little bit of math there. We got 64 minus, and then over here, we also get a 64. And so we get 0. And so when you get 0, that means we just have one real solution. And so that means we have one x-intercept. And of a set of directions, we'll ask about the x-intercepts later on. But for right now, they're just asking what are the real solutions. And so the real solutions mean that there's only one real solution. Taking a look at the next problem here, we've got a 6 in place of our a term. We've got a 5 for the b term. And it's a positive 5, so it's plus 5 there. And c is negative 4. All right, so we're going to go ahead and substitute those numbers in. So it's 5 squared minus 4 times a, which is 6, times c is negative 4. Now, one of the things that you'll notice is that whenever you have the a and the c term opposite in sign, one's positive, one's negative, you're going to always end up adding, because you see there's two negatives here, which will end up making a positive. So I know it's going to be two answers, but let's just go ahead and do some work. So 5 squared is 25 plus, because of the minus and the minus make a positive, and then we just have 16 times by 6, which ends up giving us 96. And so that's going to end up adding together to make a 121. So yes, this one has two solutions, two real solutions. And so again, the key is, if you see that minus, the a and c being opposite in sign, you know you're going to end up adding, which will always make two solutions. And the reason is because your b is being squared, and that is always going to be positive. So on this one, we have to do one extra step. We have to move that 144 over. And so now it's a negative 144. So I got x squared minus 24x minus 144. So this all equals 0. So now we're ready to solve. So we have to go 24, negative 24, and that's being squared, minus 4, AC. So A is a 1 and C is negative 144. So you see again, A and C are opposite in sign, so I know I'm going to end up adding those two numbers together. So this makes a positive. So we have a 676 is what we get when we multiply out those two numbers of 24 times 24. And we go ahead and do the 4 times by 144, and let's see what we get there. That makes a 16, and 4 times 4 makes another 16, so we get a 7, and we have another 4 times 4 is 16 plus the 1 ends up giving me 17, so I carry another 1, so that makes 5. So I think it was 576. Let me just double check that work with the 24 times 24. Let me double check that. That's 16, 8, and 9, so we have 0. And this makes 8, and that makes 4. And this, oh, I was wrong on this. It is that 576. So let me fix that real quick. So I'll continue working this problem, make sure I get the right number here. Yes, 576. And so here we have another 576. And we end up adding these two numbers, and it does end up giving us a number that is definitely bigger. So we'll just finish off the math there. It makes 12. 14 and 1 make 15. And 10 and 1 make 11. So yes, much bigger than we even need there. So 1152. So definitely two solutions here. Two real solutions. And looking at this next one, here we're having to add the 5 to all sides. So now we've got a 3x squared plus 6x plus 5 equals 0. So when we do this work, see, here we have 6 squared, and I know right away I'm going to end up subtracting the 4AC from the 6 squared. And the reason is they're the same sign. A and C are the same sign. 3 and 5 are the same sign, so we're only going to have one negative. So we better hope that the 4, 3, and 5 are big enough, or small enough, I guess, so that they don't overtake the 6 squared and make a negative, if we want there to be solutions. So we'll see if there are or not. 36 minus, now we go ahead and multiply this. This makes 12 times 5 makes 60. Well, that's going to give us a negative number when we do that subtraction. Let's see here, we end up with 24, and it's negative. So because of that negative sign right there, we'd say there are 0 real roots, 0 real solutions. Or you could say no solution would be another way to state that. Note that the answer is not 0, it's just 0 real solutions is what we're talking about there. Well, same sort of thing, just ask for how many x-intercepts there are. Well, it's the same process. Nothing different, just another way of asking it. Basically, you're going to put 0 in for y, and then you're going to figure out which is your A, your B, and your C terms. And we're just going to substitute those numbers in there. So 3 squared minus 4 times A, which is 2, and C is 1. So again, we have the same scenario. Well, we better make sure that we end up having a number that 9 is, or this 3 squared is big enough to overtake this 4AC, and it is this time. It is a 1, and so even though that's really small, close to 0, it's still 1, which means we have 2 real solutions. So look at this last one again. You put 0 here, and right away I see negative A and a positive C. I know it's going to be 2 solutions just by looking at that because they're all positive numbers. It's going to make all positive numbers. 3 squared is the B term, minus 4 times A, which is negative 1, C is 7. You see again, 2 negatives. When A and C are opposite in sign, you're going to have an even number of negatives. If they're the same sign, then we have an odd number of negatives. So what that means is we're going to end up adding those numbers together. See, 3 squared is 9, plus, because of the 2 negatives, 28. So when we add that together, we get 37, and that is a positive number. So there are 2 real solutions. So those are the types of problems that you'll see on tonight's homework. Good luck.